Hey, Sydney, you go.
Hello, everybody. Thank you so much for bearing with us. I think we had a slight hiccup there. As Yaron just mentioned, my name is Sydney. I'll be moderating today. I hope everyone has had an easy time getting logged in and is getting settled. So I'd just like to go over a few points and a little bit of housekeeping things for this session today. So this session is being recorded, and the recording will be made available to anyone who would like to revisit the session. We'll be sending both our slide deck as well as the recording. All of our participants are going to be muted today, but we encourage you to submit any questions at any time during this session, whether that be the live chat or the Q&A section. We are also going to be running some polls throughout, so we encourage your participation there as well. All questions will be addressed. We're going to have a live Q&A at the end. We hope to address as many questions as we can, but if we run out of time and your question's not addressed, we'll be sure to follow up with you and make sure all of those are addressed as well. So for those of you who may not be familiar with WINT, we specialize in water management solutions that are powered by AI. These help companies prevent water damage, eliminate water waste, and drive sustainability efforts. Our clients range from leading GCs, such as Suffolk and CBG, some enterprise customers you may be familiar with, such as Microsoft, Google, and Samsung, and we're also very excited to partner with some leading insurers such as HSB. And now it is my pleasure to introduce you to our speaker, who unfortunately had to introduce himself for a moment, but I'm excited to introduce Yaron, who is WINT's Chief Product and Strategy Officer and one of the founders of the company. He brings us over 25 years of experience in shaping tech startups and Fortune 500 companies and is a true expert in this field. So with that, I'll hand it over. Yaron, I'm so excited to see what you have to tell us today.
Thanks, Sydney, and thanks again, everyone, for joining us. We'll be covering a number of topics today, all related to risks in construction projects. We'll talk about the main risks that inflict these projects. Water damage is a key risk factor, how to mitigate those risks, and how to use water management leak mitigation technologies to do that. We'll also talk about the environmental impact of water in buildings, which is an adjacent topic, but I think it is relevant and important to many people. And finally, the best practices for implementing water management and how you actually do this and what the technologies are and how you implement them. Let's start with the high level. So it's probably not any piece of news for anyone in this webinar that construction projects are high risk intense environments. Anything from safety, accidents, injuries, God forbid, people have died on construction projects. Environmental risks, including extreme weather, flooding, hurricanes, and so on. We put a category called self-inflicted, but fires due to errors, electrical issues, and of course, leaks from pipes, as well as operational issues across the supply chain, equipment failures, security, legal, and financial topics. No need to go through all of them in depth. I'm sure you're familiar with them. But the important topic that relates to all of these issues is that they carry a very significant financial implication. There's direct costs to repair damages, to replace materials, to do the rework. There are indirect costs, missed deadlines, delays, and the penalties associated with them. There are longer term and not immediate impacts, such as reputational damage. We've seen customers who have lost future business because they've had too many issues in a construction project. Obviously, no customer wants a risk or someone who is prone to risks doing his project. And insurance companies, first of all, will charge the deductible, and we'll talk about that, but those are growing in significance. Let alone the fact that once you have a record of insurance claims, insurers will not stay muted or silent and will raise insurance fees in the future. So you will be paying at least part of what the insurance is paying you now through future projects. Nobody wants to do that. So these are a lot of implications. And with that, I'd like to actually move on to a poll. A quick question from your experience, and I'm sure there are people with a lot of experience, probably more than us here in these things. What are the main sources of risk in construction projects? So, try picking what you believe is the main source. You should see the poll pop up on your screens, and if not, you can pick it up from the from the apps tab at the bottom of the screen. We'll take a couple of seconds to let everybody vote. How are we doing there? All right, still votes coming in. Still coming in. We'll give it another 15 seconds. I still see things coming in. 15 seconds, and then we will stop. All right, I think we're good. Let's take a look at what the audience believes from their experiences, the top sources. You want to share that with everyone? And so we are seeing water come up as the top with around 60% of the votes. On-site injuries are coming up with 13%, theft or vandalism, 8%, fire 8%, and environmental events at 5%. And that is actually a fairly good statistic of how things roll out in the field from the research that we've done. Water damage, indeed, is the leading source of losses on construction sites. Amazingly enough, from all these things, fires, I mean, you know, we've seen them. When a fire happens and it's significant, it's obviously a terrible incident. The point, however, is that they are very rare. Death or injuries are also very impactful and very negative, but are not common anymore. The industry has learned to work with those. And so when we look at what the industry says, we collected a number of statistics from multiple sources just to show you what is actually at stake here. So the first thing is that on builders' risk insurance policies, by far, water damage is the #1 source of payouts and the most common claim. A study by Zurich Insurance from a couple of years ago, they said that 57% of their claims were due to water damage. So even more than what we just saw, more than the 30%. Also, insurers are reporting 15% year-over-year growth in claims. One insurer mentioned $1.28 billion in payouts for water damage. That's just one insurer. And that has impact. We are seeing between $250,000 to $1 million on a per incident basis deductible. So if you have a problem, you will not be refunded by your insurer up to that deductible, and that will be out-of-pocket payments. Even for a large project and for a large contractor, $1 million is significant out of the total potential profits of a project. And an average of $3.5 million average daily losses just for water losses. So this is big. On the right-hand side, a few more statistics. 40%, according to the National Institute of Building Sciences, 40% of construction litigation cases involve water leaks. So, I mean, these things get tight and they go to court. And if we look at what has happened over the past 5 years, because insurers have started feeling this burn and this pain, you've seen, give or take, 10x growth in non-weather related water damage deductibles. So non-weather means, not storms, but pipes breaking and water emanating from an internal source. So 10x is a lot. The $250,000 to $1 million that you're seeing on the left-hand side is the deductible. Used to be a couple tens of thousands. So, this issue has become a top of mind topic. Insurers, as we mentioned, are taking action with sticks and carrots. The sticks are high deductibles for water damages, that $250,000 to $1 million. In some cases, simple mandating. So some projects will simply not be able to obtain insurance unless they deploy and properly deploy water management solutions. And there's carrots. The carrots are discounts, reduced fees, reduced deductibles when you put in a proper water management and leak mitigation technology. And naturally, if you stay healthy and you do not claim for a long time, and we have customers like that, and in fact, we'll show some case studies, your long-term fees will go down, essentially paying at least for part of these water management programs. Let's talk about the causes. This is based on a study that we ran together with Munich Re. There will be more from that study. It's a very interesting research. It has encompassed quite a few tens and between 50 to 100 different projects over the span of around 8 years, studying where problems occur. Pipe bursts are almost 50% of the source. And by the way, I'm sorry, I did not mention Munich Re, for those of you, in case anyone is not familiar, is one of the world's largest reinsurers and insurance companies. So they've seen their share of damages of any sort, water damage included, and they ran the study with us. So back to the sources, pipe bursts account for about 50%, nearly 50% of the issues in this specific study. A few, around 10, 11% were unknown. Vandalism is a source. I won't be surprised if some of the folks on this webinar have had their share of a disgruntled employee leaving a tap open or causing damages. This has been a known problem for a while. Malfunctions such as a valve malfunction or malfunction of some equipment on the site may cause water spillage. And human errors, which account for 18%, can include things like bad fittings, bad workmanship, which also eventually may lead into pipe bursts. So these are some of the causes. I would say from what we've seen overall in the industry, the top two things are workmanship and the wrong piping and fitting technology. These seem to be the two main causes that probably together result in over 50% of the damages. Now, if you look at where losses occur, you can see in this study we broke down the project into 5 parts, 5 time equal parts, and you can see that the vast majority of damages occur towards the end, and that's natural, right? When you're just a hole in the ground or initial frame, concrete or metal, there's not much to be damaged. At a later stage of the project, you have more water running. Water will probably have been enabled on the project, let alone that you have things that can be damaged, floorings, work, plaster, paint, all of the things that are related to the finishing stage are in place. Water is running in the pipes, and that's where the damages can happen because water can leak, and it can leak and damage stuff that's in place. So the vast majority happens in the last fifth, and the last 40% of the time of the project will account for practically all damages. Let's get into some prevention strategies. What do we do about this significant problem? I'll start with water management in buildings as a general concept, not necessarily just construction, because the concept of managing water in buildings spans from the first day you have water on site coming in from temporary lines and into the building's operational phase. People who do this thoroughly and holistically start by developing a water management plan for their project. Whether it's a project for construction or a project for the operational phase, it's always good to think it through. These plans will include everything from the owner, a water responsible person, to technology, to methods, to processes, and eventually reporting. We have worked with customers who have built very thorough plans, and when you cover all of these aspects, you can achieve great results. We'll show them in the case studies. At that point, you start monitoring and you start understanding what's happening on the water consumption at the site through technology. You implement the best practices that you built into the water management plan, and you deploy leak detection and leak mitigation systems with whatever technology. We'll dive into the technology in a moment. And finally, a combination of proactive and reactive maintenance and mitigation. We naturally, as a provider of AI-based solutions, we advocate the use of AI. We believe it provides superior capabilities. from a detection, usability, and prevention point of view, as well as the data insights. So let's look a bit at the history. Think of this as a timeline. It's a virtual timeline starting a few tens of years ago. And it started with detection. Detection was a leak sensor placed on the floor. When it's touched by water, it can alert and it can notify and someone can take action. It's not very complex. It is usually mostly water closing a circuit by touching wires inside of the leak sensor. The sensor identifies the problem and it can alert. Later on, auto shutoff was added to this. So when the sensor detects water, it can now command valve to shut off. There is a challenge with this. I will not say that this is not useful. It is useful, and this technology has been around and used by many people. The challenge is that you will probably need to deploy quite a few sensors across a large facility. You will partly need to guess where to deploy them, and assuming water will flow through that location. And you won't always know the relation between the sensor on the floor that has been touched by water to a specific valve that needs to be shut off, because it's not necessarily clear where the water came from. Still, effective technology, especially for specific locations such as below an elevator, right at the bottom of the shaft. That's a place where water will accumulate, and it's a very useful place to place such sensors. At that point, we have moved on to AI and proactive detection technologies. These technologies analyze water flow. They understand the behavior of water flowing in the pipe by monitoring the water flow in the pipe itself. The chart you see here, and we'll get into a few more of these on the second hand from the right chart. On this one, you can actually see a water flow pattern, which the system can read, and it can understand whether this deviates from normal behaviors. And if it does, the system can alert. And because it is looking specifically at a specific pipe where this flow is being monitored, it can now shut off that specific pipe. So we now have a correlation between the location in which the anomaly was detected and the pipe that we are shutting off. And finally, obviously, multi-sensor fusion, where we fuse understandings from things like leak sensors and flow sensors, understanding the holistic view of all of these and how they merge together. Let's talk about AI and what it does in the context of understanding flows. So AI, by the way, I will say, is a very big word. The AI that is used in these cases is not the AI that some of you may have used with ChatGPT to do whatever it is we do with ChatGPT. They're all a part of a very broad technological framework. In this case, the AI is used as an anomaly detection technology. It learns what is normal using specialized algorithms, and then once it knows what is normal, it can identify an anomaly. And at that point, the anomaly can be flagged and action can be taken. Anomalies, by the way, and this is important, will behave very differently when flow characteristics are different. So for example, a domestic water line will typically use water and then water flow will stop, and it'll use it again and stop again. Unlike a cold water AC, HVAC loop, which will run water continuously. So these are very fundamentally different behaviors. Each of them requires a different type of anomaly detection capability. And the algorithms exist to identify these anomalies on every one of those. Once the system learns after a while, and after being fed information from past cases, I can say, we've seen many thousands of years of water flows in pipes. And so we really understand what these water flows look like. We feed the algorithm with basic information, and then it also does adjustments that are specialized and unique to that specific location and its behavior. And so if we look at the bottom chart, what we are seeing is an anomaly that is quite typical of a pipe breaking in a wall. Now, pipes will sometimes burst. In this case, as in most cases, pipes don't burst. They start by degrading. Maybe it's a bad fitting that starts to drip. and the water pressure at that location degrades the pipe. It starts with a drip, but as the degradation and the pressure destroy the location, water flow increases. And this is exactly what we're seeing here. So if you look from the left-hand side, starting to flow to the right, you can see how the chart gradually increases in flow rate. And as it increases in flow rate, after a while, the system can identify that this is not a normal type of flow pattern for this type of system or for this location, to be more specific. And so it flags. The system, by the way, was flagged to first alert and then automatically shut off after a while, giving the staff, the team or staff on the ground a chance to take action before it shuts water off. So alert goes off, nothing happens after a while. In fact, you can see how the pipe really degrades. All sorts of weird things start to happen here. The flow rate really skyrockets. There is some water on the floor. By the way, this technology will always allow some water to leak because it identifies a leak. It cannot foresee a leak. So some water flows out, but nothing disastrous, maybe a bit of inconvenience, and the system identifies it and shuts the water off as a second action after the first alert-only action. And so these kinds of patterns, and there are many of them, and they'll be unique and special, but there are groups and categories of patterns that can be detected quite easily, and anomalies can be detected. Now, when we go to implement this, what does that actually mean? An implementation will include the installation of 3 components at the site in multiple locations. The first are things that will be deployed on the pipe, a valve and a meter, and a control device that monitors the flow and sees those charts that we mentioned coming from the flow meter and may control the valve if you want it to. Important to say, and mostly not news to anyone on this call, but water systems in buildings on construction sites are multiple, variable, and can include up to 8 to 10 different water systems, from domestic water to HVAC, irrigation, and many others. And so as you go through this project, there will be a planning phase where you say, I want to protect these specific systems, these specific water flow systems, and you will implement on those systems that you want to protect. Implementation is by a plumber, install a valve and a meter, connect the control unit. We'll take care of the rest by communicating through the cloud and making sure that things are operating properly. When an alert fires off after the system has learned and normalized its behavioral patterns, an alert will fire off to the cloud reporting what was detected and whether it was shut off or not. This will be sent to multiple consumers from a mobile app used by your project manager or the water responsible person. There are KPIs, reports, and for operational use, it can be integrated with building management and ESG reporting systems. There is a 24/7 incident monitoring team that we deploy. They are remote, but they will identify anomalous situations and they will call customers when something wrong goes on, especially in those cases where you may have a guard on the site. The system fired off, shut off the valve, the guard sees nothing, he will disable the system. I've seen this happen, and at that point, you don't get into a match with the guard. If the guard says everything is okay and I'm authorizing opening of the valve, at that point, they basically disabled the system for a while. And so our 24/7 human monitoring system will identify this, and they will report back and call people, or if allowed, shut off a valve remotely. There are insights and information coming from the mobile app. It's quite extensive, so obviously this won't be a deep dive into it, but information about the site, its water consumption and water use, detailed information such as system and valve data, granular water usage across the day, and of course, alerts and water shutoff incidents reaction tools. You can shut off a valve from the system. You can open a valve if you believe it should be open now, despite maybe an auto shut-off decision. And there are all the tools here required to provide the team on the ground full control and full understanding of what's going on with the system. Going back to some research, the same team that conducted the previous study, actually it's the same study, a different part of the study with Munich Re, wanted to check how effective solutions like WINTs are in actually reducing issues. And from an insurer's perspective, you always measure this through the amount of money, the sum of money you pay with the system and without it. And so in this case, a study of 66 construction sites over around 8 years, so quite a long time, quite a few sites. You can see in these circles the pie chart explaining how they got to the conclusion, the bottom line of it all. And we're happy to do the deep dive. We probably won't have the time today. But if you look at what the results are, they are quite dramatic. 73% less claims for sites that use AI-based water leak mitigation. And if you look at the financial impact of it, a full 90% of the financial payouts were totally eliminated. So if you're an insurer and you're insuring a site that uses this type of solution, you will be paying only a tenth of the claims that you would have paid for sites that do not use this. Of course, this is statistical. It's not on a per site basis, but over enough sites, it becomes significant enough. The reason, by the way, for the difference between the 73% less claims versus 90% less payouts is because there will always be some water leaking, but it'll be much smaller. So you may reduce the claims, but a few claims will still remain. However, they will be much smaller. So you're seeing a dramatic, much more dramatic reduction in fees than in claims. Just to mention, I kind of mentioned it along the previous slides, but the solution we are discussing today is for construction. But the exact same technology can apply for the operational phase of the building. Maybe with a slight difference in deployment and the locations where the systems will be deployed. But if you think of it up front and you plan it accordingly, then you actually have a solution that will protect you from construction and into the building's life cycle. And in that respect, you will be getting a building for its lifetime that is much more water resistant, if you will, secure against water damages, let alone sustainable. And we'll talk about sustainability in a moment because that is an important element that many people consider as something they want to take care of today. Before we do that, just a question to the audience. How many of you have ever suffered from a water-related damage on your project? So feel free to answer. The poll is up. Let's see the results. I'll give you a few seconds to take this. Wow. I'm seeing the results. They're actually quite surprising and amazing. Maybe not, though. We've got 35 votes and rising. We'll give it some more. All right, 10 more seconds if you want to post your vote, and then we'll read out the results. All right, here's what we have here. Yes, more than once, we have 58%. It's exactly the point. Yes, once, we have 18%. Never, good for you, by the way, 15%. And yes, always. Sorry. And yes, always is 8%. Sorry, I got confused by that. So 8% always, which sounds a little, wow. Unless you've done a few projects, if you've always had water incidents, then yeah. I mean, it tells you what the industry is suffering from and how painful this problem is. So overall, 58% have had multiple incidents of water damage. That in itself, without the rest, is quite amazing. And I believe we can share these results, the poll results, with everyone after the webinar. So a couple of case studies about two different contractors, general contractors who deployed the solution. The first, someone I'm sure the name is familiar, is Brassfield and Gorey. They deployed WINT at multiple projects. And I think the results were very good. In fact, I won't read it for you. I'll give you 3 seconds or 5 seconds to read. Here's the testimonial at the bottom. You can see what their Vice President of Risk Management says. So we're very proud of this. At the end of the day, we prevented water damage on multiple of their construction projects. And initial successes where we were trialed have resulted in a lot of success. So we're very happy having helped this customer, Brassfield and Gorey. And here's another one, more of a European customer, but it doesn't matter. When you build, and construction is construction. And this is an even more interesting case study because this GC, just like most others, suffered from their share of water damages. 5 years ago, they came to us, trialed us on a couple of projects, saw the success, and basically standardized the solution across all of their construction sites. At this point, we're tracking many tens, getting close to 100 projects over 5 years. And the amazing metric is that they have not had a single water damage incident across all of these projects for the past 5 years. They did have, but not coming from within the building. So water coming from external sources, but no water damage from internal sources. Hundreds of thousands of dollars saved in water savings. A second benefit of what we do, which is not the primary benefit for a contractor or a construction project, is the savings. There's a lot of waste going on in construction projects, and as part of the benefits, our customers save these enormous amounts of water, their costs, and their environmental impact. So this is a customer who took it very holistically, standardized across the corporation, built processes, built systems, built reporting, and gained the benefits. I'm going to use the next few minutes, and we'll go very short because this is not the main topic and we're near the end of our time. The world is drying up. These maps are actually a few years old. 52% of the lower 48 states, of the area of the lower 48 states, are in drought. UK, Europe are at around 50%. Global weather patterns are changing, and as a result, water is not coming in where we want it. In fact, if you look at these few pictures, this is Lake Mead before and after. If you haven't seen it, feel free to Google. It's quite sad what weather changes have been causing. And, Lake Mead is feeding big chunks of the southwest part of the states. The results are seen, and this is just one example. And the amazing thing is 25 water entering a building or a construction site will go to waste. That is a lot of waste for a precious resource that's becoming even rare. And so after you waste water, using water also generates a lot of carbon emissions. It has a pretty significant carbon footprint. We won't dive into the details of it now. If you are interested, we'll be happy to share the study with you. I believe you can see the link to the study here, or contact us. We'll be happy to share or discuss it. Water causes not just water use, but also carbon emissions. And the world cares. That's why there are ESG standardization and certification. Buildings that deploy water intelligence solutions can raise their LEED score. If you're familiar, LEED is the leading ESG certification standard worldwide, and definitely in North America, in the US and Canada. Out of a total of 110 points that you can optimally gain with LEED, a full 19 to 22 points can be gained by water management solutions, which means that a building deploying these solutions, which are not that expensive at the end of the day, can raise their LEED standard ranking from silver to gold or from gold to platinum. If you put this in the building up front at a cost that is not even, it's not even marginal error on the total cost of a project, a few tens at most of valves and meters, you can gain this level of benefit from the ESG standardization, let alone all the other benefits we mentioned. So, quick summary and best practices before we open it up to questions. When you consider a leak mitigation solution, think of detection accuracy. How effective will it be? Does it support auto and remote shutoff? Does it cover all water systems in the building? Do your insurance carriers acknowledge it? And they will acknowledge quite a few systems. We're not the only ones. But ask yourself, do I get a performance warranty? If the system fails, will the vendor be able to compensate me? Will they commit to compensating me? We have a program we're very proud of with HSB, a daughter company of Munich Re, where we provide a warranty for our construction projects. If we fail, we will pay. And do you get 24/7 support? And will the vendor not just provide you technology, but also proactively monitor your site and make sure you're doing the right thing in case there's a problem? And with that, we will be happy to open it up for a few minutes of Q&A. So I'll hand this over to Sydney, who will moderate the questions and answers.
Thank you so much, Yaron. That was really insightful. And we have had several questions come in. So we are going to get through as many as time allows. And just a reminder, if we can't get to your question right now, we will be sure to follow up with that information. So the first question is actually something that came in several times, which is about monitoring large buildings or construction sites. So first of all, if you have a large building and only monitor the main entrance, how do you detect if a problem is occurring when you have water flowing from 20 or 50 different fixtures? And with that is a shutoff valve placed on each individual floor?
That's a really good question. We do not advocate a single system on the entrance to a large project. We think that is ineffective exactly for the reasons asked. If you place a single system, your shutoff will shut off the whole building, and your detection will be so granular that you won't know where the problem is coming from, let alone the fact that you will be using water in many different places. And at the end of the day, effective anomaly detection solutions do need some granularity. So if you are mixing the noise, if I can call it that, the noise coming from a lot of users, the ability to detect anomalies is not as high. So we strongly advocate slicing the building in subsegments. It can be floors, it can be risers, it can be pressure zones. We have engineers who know how to optimize a solution for a building. In fact, we will look at the building's plans and the plumbing plans for the building and work with your team to design the solution. And we can design it to protect construction, and we can design it to protect both construction and operational. So it's a much more intelligent solution than just placing a valve on the entrance. I would not advocate that at all.
Excellent. And moving on to our next question, how are the metrics collected, and how does the AI distinguish between normal water use and leaks?
The metrics are collected through a flow meter. You place a flow meter. These are standard third-party meters, the type that is mostly used for billing. But we know how to read them at higher accuracies and higher flow rate and higher time resolution. And the chart that I showed was the tip of the iceberg. Naturally, I won't be able to dive deep into technology here, but you learned what is normal. There are attributes of a flow that are normal and that are abnormal. And, you know, if people were able to train AI to have a conversation with you, not that I'm comparing, it's a different type and different a level of complexity, but you can train the system to identify anomalies across these flow charts. And happy to have a more detailed conversation at a more leisurely pace.
Excellent. And here is another question that came through several times. So what happens to this valve upon completion of a construction project? Can devices be used on other sites, or is that just the completion of that usage?
Good question. It's really up to the customer. Valves naturally sit in line. Up to you if you want post-project to remove them. I will say usually people don't want to do that because they don't want to disrupt the piping after, you know, pressure testing and so on. There are pieces that can be removed. So if we have clamp-on ultrasonic meters, these are meters that will clamp on externally. They do not do the shutoff. Shutoff has to be in line. But if you clamp on an external meter, you can do that. And the control units can also be reused. Alternatively, you can take the whole system and provide it onwards for use during the operational phase. And we've seen customers where the GC and the developer or owner share the equipment cost and the service cost, so it serves both sides. And they're in that case, everybody enjoys the systems being placed. GC gets it for the project, owner gets it for the rest of the life, and you share the cost of the equipment that way as well.
And I think we have just enough time for one final question that just came in, which is, does the AI continuously learn, or is this a one-time learning program that you'll have to repeat every month or year once the building becomes fully occupied?
The system definitely continuously learns. There's an initial learning phase, which takes about a month. When that's done, it's primed to start working, but then as patterns change, the system aligns with them.
Excellent. Thank you so much. These were all fantastic questions, and I'm so sorry that we couldn't get to everyone's. We're going to make sure to follow up with all of this information because I think we got some really great conversation starters in here. I'm really excited to look into your questions more in depth. Thank you guys so much for joining us today. We're really excited to have you here. Yaron, thank you so much for presenting, and we hope to speak with you all again soon.
Thanks, everyone.